Good morning and welcome to Algebra 1 Honors. Today I'm going to review the test prep packet and for videos purposes, that's all. What I'd like you to do after you watch the video is log into the Google Meet. Hopefully you have got your timing down and you watch the video before class so that you can log into the Meet with any questions you might have. So first page basically said, is it a function? And here are the answers. The first mapping in the upper left-hand corner, the answer is no, it's not a function because an input of 1 has two outputs, 5 and 7. Going to the mapping next to it, the answer is yes, it is a function. Each input, 1, 2, and 3, had only one output, either 5 or 7. Below it, the table where the inputs are 0, 1, 2, and 2 again is an issue because the outputs are -2, 3, -2, and 3 again. An input of 2 has two different outputs, so it's not a function. Next to that, there is the graph, and it looks like a giant loopy W. But it is a function because if you draw a vertical line anywhere on that graph, it only crosses the graph one time each time. Passes the vertical line test. The table below, inputs are 10, 13, 8, and 9. I don't have to look any further. Each one of those inputs did not repeat, so it's going to be a function. The square, any closed figure, not a function. It fails the vertical line test everywhere. In fact, 2 of the sides of that square are vertical lines, so not a function. On the bottom, the list of coordinates, the first one has inputs of 1, 2, 5, and 4. They don't repeat, so yes, it's going to be a function. The last one on the page has inputs of -1, 0, 0, and 3. Now the 0 did repeat. However, when it repeated, it had the same output of 2. So it is a function. Go to the next page. State the domain and the range. Remember, you don't repeat the values for domain and range. So the domain of the first table is 0, 2, 11, and the range is -1, 3. For the mapping next to it, the domain are just those numbers you see, 8, 9, 10, 13. The range in order is -3, -1, 5. For the graph below that, the domain are the x values of those coordinates, 1, 2, 3, 4, 5, and 6. The range are the y values of those coordinates, -1, 0, 1, 2, 3, and 6. And for the list of coordinates, the domain are the numbers 10, 40, 50, and the range 2, 3, 7. Now, the math. Given the following functions, solve the problems. Again, I'd like to make sure that you know exactly what to do. I'd also like to find the marker I was going to use. Here we go, found it. F of -1, you're using the f function and plugging in -1. So 2 times -1 plus 1. So f of -1 equals, well, 2 times -1 is -2 plus 1 is -1. That's the answer to that question. G of 8. My cat says hi. I don't know if you could hear. G of 8. Plug in 8 for the function. So we get 1/4 of 8 minus 1. So G of 8. 1/4 of 8 is 2. 2 minus 1 is 1. Understand that I'd like you to leave as your answer in function notation G of 8 equals 1. That's the best thing you can do. H of -3, so we're using the H function. So H of -3 is 2 times -3 squared minus 10. Please remember that the -3 gets squared before you multiply by the 2. It's PEMDAS. -3 squared is 9. So H of -3 equals 18 minus 10, which is 8. Then we have G of 10. So choose the G function. It's 1/4 of 10 minus 1. 1/4 of 10 is 2.5. Minus 1 is 1.5. And then f of 7, so we use the f function again. F of 7 is 2 times 7 plus 1. So f of 7 is 15. So that's the top row here. Make sure you got those answers. Okay. Moving on to the bottom row. where it's more likely to have some issues. With the bottom row, it's giving you the outputs, not the inputs. So when it says f of x equals 11, you're taking the f of x function, which is 2x plus 1, and you make it equal 11. That's how you set this problem up. Subtract 1 from both sides, and 2x equals 10. Divide by 2, x equals 5. G of x equals 10. Take the g of x function, which is 1/4 x minus 1, and make it equal 10. Add 1 to both sides. 1/4 x equals 11. Clear the fraction. We multiply by the denominator, which is 4. X equals 44. H of x equals 22. Take the h of x function, 2x squared minus 10 equals 22. Add 10 to both sides. 2x squared equals 32. Divide both sides by 2. X squared equals 16. Take the square root of both sides, and you get positive and negative 4. Don't forget, the square root of 16 is positive and negative 4. So there's two answers. You need both. Okay. G of x equals negative 6. So the g of x function, again, is 1/4 x minus 1 equals negative 6. Add 1 to both sides. 1/4 x equals negative 5. Multiply by 4 to clear the fraction. X equals negative 20. And f of x equals negative 6. Take the f of x function, 2x plus 1, set it equal to negative 6. Subtract 1 from both sides. 2x equals negative 7. Divide by 2. That's negative 3.5. So that's all the math and answers for the bottom of that page. Turn the page over. Final page. Here's what I want you to understand. How can you tell if a relation is a function if you're given a graph? If it's a function, it will pass the vertical line test. Any vertical line drawn anywhere on that graph will only intersect the graph one time each time. A mapping. Mappings show you if the inputs have one or more outputs by the arrows that leave the input. So what you're looking for is you're looking for only one arrow to be leaving each input, no more than one arrow per input. Coordinates and table of values, same answer as each other. If the x repeats, it repeats with a different output. That's not a function. So if you want to make sure it is a function, you want to make sure that if the x values repeat, they repeat with the same output. Again, it's a function if the domain, the inputs, the x values, only repeat with the same output. Or they don't repeat at all. Obviously, if they don't repeat at all, it's a function. The only issue is when they do repeat, what is the output? Okay, now the piecewise function down below, obviously numerous pieces, lots of pieces here. All you're doing for the 6 problems below it is you're reading the graph to see what the inputs or outputs are going to be. So, g of 5 means go to 5 on the x-axis and see where it touches the graph. That's 2. G of 5 equals 2. G of negative 3. Go to negative 3 on the x-axis. And the output is also negative 3. So the answer there is negative 3. G of 1. Go to 1 on the x-axis and see where it is in the graph. That's actually at 2. So the answer is 2. And G of 0. Well, when the input is 0, the output's also 0, because that's where it's crossing at the origin. The answer is 0. G of x equals negative 3 is a little bit more challenging because you're looking for where the output is negative 3. Now the output, the y value, is negative 3 down here, and it's these values. So what you're going to say is any x that is less than or equal to negative 2. Because starting at negative 2 and moving to the left, it's at negative 3 on the y. The last one, g of x equals 8. So where is the input equal 8? Well, way over here where x is 6. Okay. So far as intervals of increasing, decreasing, or constant, I will show you my answers. But increasing, again, is where it's growing in values. So here are the increasing intervals. There's 3 of them. Okay? It increases from -2 to -1. And again from 0 to 1. And again from, what does that say? 4 to 6. Okay? I put brackets around the whole thing because the whole graph is filled in solid. So it's okay to say it's brackets around everything there. Areas where it decreases. There's only one area where it decreases, and that's this little loopy part down there. So it decreases between 3 and 4. And constant. Well, it's actually constant in 2 spots. Okay? It's this part over here, it's constant, and this part over here, it's constant. So areas where it's constant, it depends on if you think this has an arrowhead, you could say negative infinity. If you don't think it has an arrowhead, you could say, you know what? I didn't put that on my key just now. So I'm going to go to either -5 to -2. I left it off my key. Or you could say negative infinity to -2. There's 3 areas. That's the first area. The next one goes from -1 to 0. And then again, from 1 to 3. Okay? And make sure you get all the areas unlike I did. So, if there's any questions or problems or concerns, or you want more help, or you want anything, log into the Google Meet today. Otherwise, review this packet because it's the basis for your mid-unit test, which is tomorrow or Friday, depending upon your cohort. Any questions, let me know. Send me an email or log into the Meet. Otherwise, have a great day, and I'll see you soon.